Hello guys, so today we'll be dealing on solubility in chemistry, right? Everything has to do with solubility. Talking about the definition, explanation, and then the calculation involving solubility. And we'll be solving problems based on WAEC and JAMB questions, right? So that those that are writing exams can easily float what it is, right? So what is solubility? Let's just jump straight to it. What is solubility? Solubility is generally the quantity of a given solute that will saturate a given solvent at a particular temperature. Or we can say solubility of any substance is the amount of substance, which is solute, either in mole or mass, that will saturate 1000 cm³ or 1 dm³ of the given solute at a particular temperature. We can also define solubility as the ability of a solid, liquid, or gaseous chemical, which is solute in nature, to dissolve in solvent, and solvent can be liquid at a given temperature to form a solution, right? So solubility has to do with three main important words. Has to do with solute, solvent, and solution. So what is a solute? We talked about what solubility is, right? The amount of solute that is what dissolved in what? In solvent, right, to form solution at a given temperature. Right, these are the three things we're looking at as regard to solubility. We talk about the amount of solute, right, that dissolves in solvent to form solution at a given temperature. So the solute there can be, we talk about the amount of solute. The solute is a solid substance, right? We can talk about, let's talk about salt, for instance. Salt dissolving in water, which is the solvent. Water here is the solvent. The solute is salt. The solvent is the water. If we dissolve salt in water, we're going to get salt solution. Right? Solution is a product of the solute and the solvent. Right? So when we dissolve a solute, which is salt in nature, in water, which is our solvent, right, we're going to have a solution. That's what a solution, salt solution at a given temperature. Right? So solubility has to do with dissolving a solute, a solid material, right, or a solid liquid or gaseous material into a solvent. The solvent is always water in nature. Many of the times it is water in nature, the solvent, right? So if I want to define solute, I can say a solute is the substance that dissolves in solvent, right? A solute is the substance that dissolves in a solvent. And so what's a solvent? A solvent is the substance being dissolved in. That's water in nature, right? So we dissolve salt in water to get salt solution. Even sugar, we dissolve sugar in water to get sugar solution. There are other examples, as you can see in your screen. I'm just giving you some other examples that we can dissolve in water to have their solution. So that's just that about what solute, solvent, and solution is, right? So I come again, I rephrase. I said the solute, which is the substance in nature, can be salt in nature, dissolves in the solvent, which is water, to have a solution at a given temperature. Right, so we can dissolve sodium chloride, which is our salt, normal salt, table salt, in water at a given temperature. That's basically all about solubility, right? So that's just all we need to know about solubility. Now also understand that the solubility of a substance also fundamentally depends on the substance used, as well as the temperature and pressure. Right? In solubility, we'll talk about the solute, which is the substance used, because most solutes, they don't dissolve in solvent, right? And most solvents, they don't saturate solutes, right? So it depends. For solubility, it depends on the solute that depends on the solvent, right, to give us solution, as well as the temperature and pressure involved. So let's look at some common solutes, solvents, and solution that they form. Let's take, for instance, we have salt. Let's look at our solute. This is our solute. The line of our solute, our solvent, right, and then our solution, right? If we take salt, for instance, as our solute, dissolves in water, I told you we are going to have salt solution, right? Also, if we look at acetic acid, right, acetic acid dissolving in water, we are going to have vinegar, right? Vinegar, right? Also, if you look at cocoa, COCOA, cocoa powder, and what? And milk, right? We're going to have chocolate milk. chocolate milk as a solution. That's what's going to give us. Also look at sugar, right? Sugar as the solute dissolving in water, right? If sugar dissolves in water, we're going to have sugar solution. So on and so forth. So we have different solutes for different solvents that produces different solution at a particular temperature, please. Particular temperature. So looking at this, it's all about solubility. So let's paraphrase. Solubility is basically the amount of solute that dissolves in a solvent to form a given solution at a given temperature. That's all about solubility, right? So if you ask to define solubility, generally what it means, you can just do that, right? But that's just the general definition of it. We'll be looking at the calculation that involves solubility in a bit. I'll see you in this class, guys. Thank you. See, let's look at calculations in solubility, right? So in solubility, there are two things we need to understand. That solubility is given in mole per dm cube, in moles per dm cube, and also solubility is given in grams per dm cube. But there are two things we must look at in this form, right? If we are given a mole per dm cube, the formula is simply the mole over volume. That's the formula for solubility. Mole over volume, right? Some textbook we try and break it down. You know what mole is? We know that in our former video, which is on the link below, we know that mole is simply mass. Mass over what? Over molar mass. Right? So if we fix that here, arranging everything, our solubility is just going to be mass over what? Molar mass times the volume. That's just the simple formula for it, right? If we try and stretch it further, it's going to be mass over molar mass times volume. Now this is in one phase. This is one solution of this is one formula of the solution. If the solubility is given in cm cube, we convert this formula by saying mass times 1000 over molar mass times volume. Right? This is the formula we use if the volume of the substance of the solvent is given in cm cube. This case is when we have our volume for cm cube. Right? If we have for cm cube, we convert using this formula. But the volume is given in dm cube, we just use this formula. I'm going to be showing you questions that relates to this. Right? Secondly, we have solubility in grams per dm cube. The word gram then means mass. The unit of gram is mass. So we have solubility also as mass over what? Over volume. Right? There are two cases we use solubility. And also we're dealing with questions as regard to this. If the volume of the water or of the substance is given a cm cube, we simply convert, do the same thing. Mass times 1000 over what? Volume. That's all about solubility. It's in two phases, right? So this phase, if it is not given in dm cube, let's assume this one is in dm cube, right? But this one is when it is given in cm cube. So let's use some questions to explain what we just did here. I'll see you in the next video, guys. Alright guys, so let's look at number one question in contest. It said a saturated solution of sodium tricarbonate 6 contains 20 grams of Na2CO3 dissolved in 500 cm cube of water. Let's look at the volume of the water. It's given in 500 cm cube. So I told you if it is in cm cube, we use what? We use mass times 1000 over molar mass times what? Times the volume. I told you this, right? Of water at 27 degrees Celsius, right? Let's just leave this one aside as a temperature. We're asked to express the solubility of the salt in what? In mole per dm cube. It's very simple. First of all, step one in solving this is that we invoke the formula. We said that solubility, right, is in what? Because we are saying our volume of water in cm cube is going to be what? Is mole over what? Over volume. right? And we know that in mole we have mass over molar mass. So let's stretch this out. I told you that the easiest way to do it is to put your mass over what? Over molar mass times what? Times the volume, right? But then I said something. I said if the volume of the water is given in cm cube, we multiply by what? By 1000, right? And I'm going to be explaining why we are multiplying by 1000. So number step one, we have the formula. Let's look at what's the molar mass of the salt. Look at it, Na2CO3. We have that our molar mass is going to be what? Na2CO3 is going to be Na2, that means 23. We say that sodium is 23. We're going to add their atomic mass, right? So we have 23 times 2. The reason I'm multiplying it by 2 because it is 2 here. Plus C is 12. And then plus what? O3. That's 16 times 3. 16 times 3, right? If we do take the arithmetic sum of all of this, we're going to have 106 gram per mole. 106 gram per mole. That's the molar mass of this the compound there, right? Having taken the solubility, that's the formula of taking the molar mass, let's try and invoke them. We know that our mass of the substance was given as what? As 20 gram. This is the mass of the substance. It was given as 20 gram, right? So mass is 20 grams. So let's get on with our solubility. Therefore is mass, and then the mass here is what? Is 20 gram. 20 times 1000 over our molar mass, which is 106. 106 times what's the volume there? The volume is what? It's 500. 500. Right? I told you that's the volume of the substance. So I was volume of the water given, right? So 20 is taking out 2 zeros from here. 5 here is 1, and then 5 here is 2. So let's multiply. We have 20 times 2. 20 times 2 over what? Over 106. 106. Doing that, we're going to have 40 divided by 106. Mind you guys, if we divide this 40 using your calculator, if you divide this, we're going to have 0.38 what? Mole per dm³. Right? The question says we should express this answer in mole per dm³. So looking at it there, if you look at it, it said express it salt in mole per dm³, and that's the answer we just got for number 1. So I want you to just look at this carefully, try and solve the question again, iterate yourself with it as you jump to the number 2 question. I'll see you in the next question, guys. Thank you. Alright guys, so let's look at the number 2 questions given on the board. It said if 60 gram of copper 2 tetrasulfate 4 dissolves in 20 dm³ of water to form a saturated solution at 20 degrees Celsius, calculate the solubility in mole per dm³ of CuSO4. And these are their atomic mass units given here, right? So I mean, looking at this, I told you guys that there are steps to solving this. This is the mass that was given. So let's solution. Right? Let's start with our parameters. That the mass given, the mass is 60 grams. Right? We have 60 grams of mass there, and also we have the volume in dm³. So we don't need to multiply by 1000. Right? We have our volume. Our volume given was what? 20 dm³. Right? And then what else? Our molar mass. You have the temperature. We don't need the temperature, but let's just put it down. Our temperature there is what? Is 20 degrees Celsius. We have 20 degrees Celsius as our temperature. So what's our molar mass? So our molar mass there, our molar mass is what? CuSO4, right? CuSO4. That's copper. Copper there is what? Is 64, right? 64 plus our sulfur is 32, right? And our oxygen is 16 times 4. So we have 16 times 4. Arithmetically, if you take the arithmetic sum and product of that, we're going to have 160, right? 160 gram per mole, right? That's the molar mass given. So having known all the parameters we need, let's get our formula. That our solubility is what? Mole over volume, right? That's the formula. The mole over volume, but then mole is mass over molar mass. So if you try and rearrange it, is going to be mass over molar mass times what? Times volume, right? Times our volume. Right, that's what we're going to have. So let's try invoking our values into it. All right, the values given was what? The mass there is what? What's our mass? Our mass is 60 grams. Since there we have our volume is in dm³, not in cm³, we don't need to multiply by 1000. I told you, if it is given in cm³, multiply by 1000. Right, that's to convert it. But if it's given in dm³, no need. And the reason is because, let me just tell you, the reason is because 1 decimeter, look at decimeter, 1 decimeter is equal to what? 10 centimeter. Right, 1 decimeter, just one of these is equal to what? 10 centimeter. So by the time we are multiplying it by 3, we are also multiplying this by 3. So we have 1 dm³ giving us what? 10 raised to power 3 cm³. That's approximately 1000 cm³. Are you seeing? That's why we're multiplying by 1000. So I just don't want to go far on that. So let's just leave that one. So in doing this, our mass there is what? Is 60 grams. So we have 60 over what? Our molar mass, which is 160 times our volume. What's our volume? 20. Right? We have 20. So what do we do mathematically? We know that 0 will take off 0 and then we start multiplying. So if we do that, what are we going to have? Using your calculator, we're going to have 0.018 mole per dm³. If you arithmetically do this by dividing, we're going to have 0.018 mole per dm³. Very simple. It's that easy, right? This is our answer, right? 0.018 mole per dm³. So that's the solubility needed to saturate that. So looking at this, very easy, right? There's no big problem to this. Try and look at it carefully, iterate it, solve it, and then you see how we go about this. So the next question, I'm going to be dropping one other question. We'll do 4 other questions. We'll continue to do questions and see how we can, get familiar with how solubility question works. I'll see you in the next video, guys. Thank you.